This video will show you how to use the inbuilt variable selection methods in SPSS. This video continues the example presented in video 1. In the previous video, we created a model with all predictors included, but we had a problem of multi-collinearity and a low correlation for some variables. There are 3 variable selection methods offered by SPSS to produce a model that only has significant predictors. To look at the options available, click Analyze, Regression and Linear. If they're not already there, add VO2 max as the dependent variable and the other variables as the independents. See video 1 for the appropriate options, statistics and plots to add. In options, we can set the criteria for entry and removal of variables. We will leave these as the defaults. The first method offered by SPSS is stepwise. Here, the independent variables are added to the model one at a time. First, the significance values are calculated for each variable using a model that only has one independent variable and a constant term. The variable with the lowest p-value is added. If we run the regression analysis in SPSS with the stepwise entry method, we get the following output. The first table with variables entered/removed shows that the first variable to be added was 1 mile walk time. For the next step, the significance values are calculated for each variable in a model with a constant and 1 mile walk time already included. The variable with the smallest p-value is again added. Gender was the next variable to be added. The process continues in the same way until there are no more variables with p-values less than 0.05. The model summary and ANOVA are given for the model created at each step and can be interpreted as before. The coefficients table gives the coefficients of the model after each step. The excluded variables table shows the significance values for the variables that are not included at each step. In the final row, we can see that height and body temperature are not included in the final model as both have p-values greater than 0.05. The second method available is called backward. First, all the variables are entered into the model, then the independent variable with the smallest partial correlation is considered for removal. If the p-value for this variable is less than 0.05, it is removed. A new model is then created with all the remaining variables and the process is repeated. We stop when no more variables meet the criteria to be removed. To run this in SPSS, again click Analyze, Regression, Linear and change the method to backward. Click OK. The first table in the output shows the order the variables were removed. We again have the model summary and the ANOVA. What we are interested in is the coefficients table. This will show how the variables have been removed. In model 1, height has the smallest partial correlation and a p-value greater than 0.05, so this is removed. In model 2, body temperature has the smallest partial correlation and a p-value greater than 0.05, so this is removed. In the third model, all significance values are less than 0.05, so no more predictors are removed. This information is summarized in the excluded variables table. The third inbuilt method is called forward. This works by adding variables one by one. First, we look at the partial correlations and the variable with the highest partial correlations is considered for entry. Then, like stepwise, we look at the significance value for a model with just a constant and this variable. If the p-value is less than 0.05, we include the variable. The process is repeated until no more variables meet the criteria for entry. We run the analysis in the same way as before by going to Analyze, Regression, Linear and this time changing the method to forward. Click OK and we get the following output. The variables entered/removed table shows the order of entry. The ANOVA and model summary are shown and the coefficients table shows the partial correlations for the included variables. The excluded variables table shows the partial correlations for those excluded. We can see 1 mile walk time was included in the first step as it has the highest partial correlation. Minus 0.783 is larger in absolute value than any of the other partial correlation values. SPSS also offers an option to manually remove variables. Go to Analyze, Regression and Linear add all variables in the first block with the method enter. We might want to try removing weight instead of height and see what effect this has on the model summary and coefficients. Use a second block and add just the variable weight and change the method to remove. Take a look through the SPSS output to see what difference this makes. You can use this method if SPSS removes predictors which you do not want to remove for other reasons. In summary, there are 3 algorithms offered by SPSS to remove insignificant predictors. They are stepwise, backward, and forward. In general, you'll get different models using each of these methods, and there is no right or wrong choice of method. It is statistical best practice to state in the design that each variable selection method will be tested and then to comment on the differences in the models in the analysis. In this case, we get the same model using each method. This is a useful conclusion as it suggests we found the best model. If you get different results from each method, you should think about comparing the coefficient of determination and the standard errors for each. The main differences in these methods is the order in which the variables are added to the model. Forward and stepwise begin with an empty model and predictors are added one at a time, whereas backward begins with a full model and predictors are removed. The main difference between forward and stepwise is that in stepwise we re-evaluate the significance of all predictors when a new predictor is added. The final method we looked at was enter/remove. This gives a manual way of building models. We can use this when we want to look at the effects of including different variables. We also use this to manually perform forward, stepwise, or backward entry. The next video will cover interpreting a linear regression model and checking the assumptions.